Hi guys, welcome to DNCL Technologies, Bangalore, India, and this section will be continue the Buccaneer design. So next, I think previous section up to I stopped here. I think we can measure the pulsating DC will come. Next, we are using for the snapper circuit, and we are using for a resistor and capacitor and diode for any per peak voltage peak will come. So once that this transformer will be uh, will be release the reverse inductance, so that time only we won't affect this transistor or any controlling unit. So on duty only we're using for snapper circuit will be remove or stop the voltage spikes. Will be switching, whenever switching is on condition, that time will be here will be developing the transformer will be developing or producing the that is called for a inductance. So that things we need to stop duty only using bus snapper circuit. Next, coming to my transformer primary secondary, this will be isolated for primary section and secondary section. Next, coming to diode and capacitor, this will be will allow for only for positive cycle, and this capacitor will be store the voltage how much unit. And this for a ceramic capacitor, this for relative capacitor. Next is a feedback circuit. I think feedback circuit already I posted one video, please check it out. This how we need to calculate. So next, coming to this one as a transformer design. And transformer design, I think we want to know, but the first step we need to choose for core and number of turns. And core means we can choose for core bobbin core. So next, we need to calculate the primary how much number of turns will be there. So that is formula is V in into T on into delta B into ACB, and V in, I think we know here 230 volt, right? So this is a formula B in 230 volt AC. And next is T1 means is on time of transistor or MOSFET or controlling unit. So we can make it as 50%. 50% means 0.5. That can make it. And next one is delta B and ACB. What is the things? So I think that formula we can applicable. So we can use for that is ACB. ACB means that is the chart will be there how much score will be there, no? That is we can make it as 11.8 118 is a score mm. So that is called for ACB, that is effective area. And then next one is a delta B. And delta B is the, I think commonly 200 to 400 milli Tesla will be there T. So we can choose for here 200 milli Tesla. So this is a formula we can applicable means. And before starting V in the input voltage, right, we have some switching loss, right? Switching loss and primary switching loss will be there. Switching loss. Next one is, I think, primary resistance loss. So this both things you can at least consider as a 10%. You can minus 230 volt means you at least make it as 220 volt calculation part. We'll get for primary how much turns we need to use. For NP will get for approximately 63 or 68 turns we need to use. So same like that we need to follow for secondary turns. I think formula we can use for that one. That is also same. We out maybe how much output we are using into T off divided by this is off condition, the secondary section, and delta B into ACB. So we know V out. So here some I think 5 volt output means we need to you choose for, I think, some switching here loss will be there right here also. So that minus it 4 into T on minus 2.5 divided by that is a 200 Tesla, and the same thing will follow for secondary winding also. Number of turns will get it. Understood? Next, coming to how much width you need to how much wire width length called. Okay, now so number of tons tons per one bobbin core into number of tons. So we can use for how much width will get this one. This formula we can use. We'll get it. Next, I think we know primary turns and secondary turns, and next we know the bobby and core. It should be applicable, not the transformer is there, no. So like that, right? So like that, the transformer is there, no. This is bobby and so is there, no, here. So this will be whatever turns will be inside, we need to fix accordingly. Only we do calculation part, right? So next, this one transform design is over. Next we need to use for diode. I think diode, I think whatever it is coming, no, that is example. My output load will be 5 volt 2 ohms means, so at least triple means 4 ohms you have to choose this here diode, these things. The next, coming to a capacitor also, at least here use 5 volt means at least I use for 20 volt, and I need to have some calculation for capacitors. We can discuss for next section. So after that load we'll use for capacitors, or our next feedback circuit will be there. I think we last section on the discussed it. So it is for, so this for anode cathode we reference this, make it as a 5 volt, this R1, this R2, right? I think this one. So this you need to give for optocoupler circuit. Next we give for switching circuits. Understood? Next, so then, so we took a calculator, we have formula, but R1. So now I think we know the I reference we want to know, and V reference. So I reference is 0 to 10 milliampere, 0 to 10 milliampere, right? Next, V reference, I think we know here to here, here to here 2.5. So we need to assume as a 2.5 here. So this will be support for 2 volt to 40 volt V reference. That formula we can substitute. We get it for R1 RT equal to V divided by I reference. We know V reference 5 by 0.7. I am assuming for I reference we'll get for maybe 637 will get for ohm. This for total of resistance for that R1 and R2. Now we can divide by will 2 means we'll get for R1 R2. This also one shortcut, and next we'll use for formula also we can use. So that thing, next after that TL431 is over. After coming out of coupler, next switching the pits. So okay, this is working. This is the scenario. So after that, how we need to do for validation for these circuits? So we need to do for one is a load regulation and line regulation, and output ripples and input ripples both, and transient voltage, interest current. So this is things and all we have to assume as things. And frequency, switching frequency you have to choose for 50 Hz only, AC 50 Hz or 60 Hz. So what are choosing here, we'll let discuss for next section. I think line load regulation, right? We can discuss what is a load regulation. See, example, I'm doing load regulation. My output load will be, I'm changing output load. My output load means a 5 amp of this load will be support 0.2 or 3 milliampere to 5 amps. This is milliampere to 5 milliamp support means amps. So support means, So I'm wearing this one too. That time my output voltage, how much is varying? So that is called for load regulation, how much percentage. So we can discuss that some samples. And same thing are also line regulation also. So my input voltage, example 230 volt, 185 to 415 volt will be there. I'm changing how much my load will be varying, not load varying, the output voltage, that is 5 volt is said, right? Output voltage 5 volt, maybe 4.95 to 5.05, how much is varying. So these things are line regulation. Thanks guys watching for DNCL Technologies. Keep support and please subscribe our channels, and please click on bell button. Thanks for watching. Please keep on give me supports. If you have any doubt, please give me the comments.